Okay, so let's welcome everybody to this YouTube channel. And this YouTube channel basically is Everyday Lead Code. And here we go. The first way. This today we are going to solve this question: short colors, the 75th question of Lead Code. Again, it's a very uh, famous question, and it has a lot of likes. If you see, I'm liking it right now. It's a very good question to understand. So just like every time, let's try to understand what the question is, and once we understand the question, we will go about and think about the solution. So in this question, we are given a array. In this array, you have either a 0, 1 or a 2, and what you need to do is you need to sort this array. But you need to sort this array in place. So they have given this example. Okay, of course, I'm just simplifying the question. If you read the question, it's the red color. Red means 0, white means 1, and blue means 2. But all of these are just trivial informations to us. What we need to do is just sort the array uh, using in place sorting. So for an example, 2 0 2 1 1 and a 0 should be, the output should be 0 0 1 1 2 and a 2. So this should be the output. So ideally it's sorting, but it's not exactly sorting, to be honest. Anyways, if I call it sorting, let's just call it sorting, because yeah. Now in this problem, one way to go about this is to loop through this input array once, count the number of 2's, the number of 0's and the number of 1's, and then keep on overwriting your output array should be the same array, but you keep on overwriting this array. So for example, if 0 has come twice, so you go to a 0. Now within that 0 you put 0 here, put 0 here, then you go to a 1. Since 1 comes twice, put 1 here, put 1 here, and then you go to a 2. 2 has come twice, then put 2 here and 2 here. In this fashion you can use this, but that is a very naive approach. What we want to do is do it in place. So if you observe the question very carefully, you know that there are only three numbers: 0, 1 and 2. So by some way, if I can sort zeros and I can get all the zeros to the left and all the 2's to the right, the ones automatically are placed in the middle. So all I want to do, because there are just three numbers, I want to keep all the zeros to the left and I want to keep all the 2's to the right. That's all I want to do. I do not want to complicate this. Just get the 2's, get the zeros here, get the 2's to the right, and the sorting will happen automatically. So how do I deal with it? Let's think about looping through it. So whenever I loop through this array, I know there are only three cases that can be possible. So either I have a 0 in a particular position, either I have a 1, and or I have a 2. So I know that when I loop through this once, I can have only these three numbers. So there can be only three cases and not more than three cases. So I need to handle these three cases separately. So what we do in this solution is, when we find a 2, we need to put the 2 behind. When we find a 0, we need to put a 0 ahead. And when we find a 1, we simply keep it as it is and move ahead. That's all we are supposed to do. So what we can do is we can keep 3 pointers. One would be your start pointer, one would be your end pointer, and one would be your index pointer, which will always point, which index pointer or one a pointer that will keep on increasing in every loop. So it's the basic index pointer. uh, so the start pointer will tell me that if there is a 0 that the index pointer encounters, then you put it at the start pointer and increment the start pointer by 1. If there is a 2 that the index pointer will encounter while going through, then you put take that 2 and put at the last pointer. When you put that, you decrement the last pointer by 1, and that's how we are going to solve this. So let's just have a look at the code once. Okay, so definitely there is a front pointer, there is a last pointer, and there is an index pointer. I am initializing it to 0 as of now. Now if I go into my while loop, the while loop condition is simple. If the front is less than the last, you go into the while loop, and if the index is lesser than the last, you go into the while loop. So you can never cross, front and index can never cross the moment they cross, I come out of the while loop. So what happens is, the first case is that the index value is 0. I mean, index is pointing at 0, it's a 0. So I swap the index with the front. The front is incremented and the index is also incremented. The other condition is that index happens to be 2. So I have to swap with respect to my last pointer, and I decrement the last pointer by 1, but I do not increment the index. Now, alright, so let's walk through an example rather than, yeah. So one example is 202110. So I initialize my start pointer here, end pointer is here, and the index pointer is here. So the index pointer is 2. So what I do is I swap with my last guy. So when I swap 0 2, 0 comes here, 0 is already here, 2 1 1, and this swap has happened. The index pointer is still the same. I do not change the index pointer as of now. So it sees a 0. Because it sees a 0, what happens is it comes into the first case, that the case that the index pointer is at 0. So when the index pointer is at 0, the front is also here, and the index is also here. So swapping will really not make a difference. But with the swapping, the index pointer and the front pointer, both of them are incremented. So 0 0 2 1 1 2, and the index pointer is here, the start pointer is here, and the end pointer is here. Again, the case that index pointer is equal to 0, is pointing at a 0. The moment the index pointer I swap with the front is also at the same position. So 0 remains as it is, 2 1 1 and 2. Now if the index pointer is incremented, the front pointer is also incremented, the end pointer is here. So index pointer and the front pointer, both of them are here at this moment. The last pointer is here. So I come into the second case, that the index pointer is pointing at 2. So the last pointer, the moment I swapped it, the last pointer came here, my bad. So the last pointer was here, at this point here, at this point last pointer is here. So the last pointer is at this 1. I swap it because with respect to the last pointer, so 1 comes here, there is a 1 here, and there's a 2 comes here, the 2 comes here. Now because I swap, I decrement my last pointer. So last pointer was here, now the last pointer comes here. So at this moment the last pointer is on this number, my index pointer is here. I check my index pointer, it's not in any of the two conditions. If it's a 1, you simply increment. So I simply increment. When I simply increment, the last pointer and the index pointer becomes equal, but still I increment because it's a 1 that I encountered. So because I encountered a 1, I simply increment. I come out of the loop and the answer is 0 0 1 1 2 and 2. So that's the idea here. So ideally there were 3 pointers. The index pointer, there were 3 pointers. The start pointing to the position. So the state of the start pointer will always be pointing to the position where the next 0 is to be inserted. End will always be pointing to the position where the next 2 is to be inserted, and index will be a pointer that will be incremented if index will be a pointer that keeps on incrementing in all conditions except when index pointer is pointing to a 2. The reason why does that happen? So for example, if this was a 2 and if there's a 1 here, the last point, since you find a 2, you put it at the last pointer. So the moment you put it at the last pointer, this 1, there's a 1 0 2 1 1 and a 2 comes here. You decrement the last pointer here. This is a different example, please note. Okay, you decrement. So now if you would have changed the index pointer here and incremented the index pointer, we would have missed this 1. So that is why we do not increment the index pointer. So the index pointer is not incremented at that point. Since it's a 1, you now increment it. My start pointer is still here. When it sees a 0, then it swaps 0 1 and so on. We have gone through this example, we have understood what it is, so we have understood the structure. So that's all for today, and I hope you like this video. I hope you really understood the problem. And yeah, the only thing, the big picture over here is get the zeros to the left, get the 2's to the right. Ones get automatically sorted. So that's it for today. Thank you.